Welcome, 8th graders. We are going to do a little bit of a review on rate of change and proportionality and what makes something linear so that you can take notes and get a little bit of extra practice. Then you'll get your quiz back and you'll make corrections on a separate sheet of paper there. So make sure that you take good notes on this and that you're really listening because some of the mistakes that we are making are just a confusion of what examples make something proportional or what makes them linear, because that's not the same thing. So remembering rate of change is the change in y over the change in x. A lot of you are good about knowing that. Sometimes when given a table, you are putting x over y. You always have to make sure that your simplified rate is y over x. Okay? So when you were asked to find the rate of change between a certain time frame, some of you didn't maybe read the directions of what it was. So here we have the year given. So when it tells you to find the rate of change from 2000 to 2002, none of the rest of the stuff matters, only this change matters. So you really have, in 2000, there were 317 million attendance, and in 2002 there was 324 million in attendance. So again, you need to know that we're looking for the change in attendance over time, our y value over our x value. So then we plug in those values. We have our x and our y's, and that's what they did. Y2 minus y1 over x2 minus x1. And took those out and simplified. They got 7 over 2. Since this is a rate of change, it should be simplified, and it should be, it's not a slope. We didn't ask what the slope of a line was. We asked for the rate. So it should be 3.5 million people per 1 year. But what does the rate of change mean? You guys were asked that question on the quiz, and many of you put change in y over change in x. Yes, that's true, but we're still talking about this problem. So what does it mean in relation to this problem? And when it's in that same spot, that's what it's talking about. So an example of how you should write a sentence to describe that would be, over this 2-year period, attendance increased by 7 million for a rate of 3.5 million per year. Or you could say, between 2000 and 2002, there was a 3.5 million people growing in attendance each year in that time. Something that says that you know it was a 2-year period and you know that there was growth and how much the growth was per year. Okay, you're describing what it means for that situation. Linear versus nonlinear. Being linear is not the same as being proportional. To be proportional, yes, it has to be linear, but things that are linear can also be non-proportional. The telltale of something being linear is having a constant rate of change. This is not a reason for proportionality, because this can be non-proportional too. Okay, linear lines, a line again that starts not at the origin but it's straight, this has a constant rate of change, but it's not proportional. So you cannot use constant rate of change for a reason of proportionality. You can use constant rate of change to describe if something's linear, a straight line. And that is when you're looking at x is going up by 3, up by 3, up by 3, up by 3. Y is going down by 2, down by 2, down by 2, down by 2. In this case, you would say this table has a constant rate of going down 2 over 3. Whereas this table, up by 2, up by 2, up by 2, and up by 2, x is changing at the same rate, while y here went up by 2, then by 4, then by 2, then by 4. This does not have a constant rate of change. So it is not linear. So yeah, this one wouldn't be proportional either because it's, first of all, not linear. This one, however, is going to be linear, but if you notice, if I went back 3, I'm going to be at -2, and if I went back to here, or up 2, I'm going to go at -4. This one doesn't go through the origin, so I couldn't just look at this and say that it's proportional, okay? I would have to simplify the ratios. So constant rate of change is not the same thing as being proportional. That's not a reason. That just describes if it's linear, if it's a straight line or not. Now onto the good stuff. Proportional versus non-proportional, okay? These are the 3 reasons you'll generally give for being proportional. Is it written in y equals kx or y equals mx? So there's just a rate of change, just a slope, comparing, changing x and getting out y. If the graph actually goes through the origin, 0, 0, and in a table, if the ratio is constant, or if the ratios are all equal. That's where we're getting a little bit mixed up. Saying x and y increase by the same amount is describing it's linear. Okay, saying the ratios are equal describes it's being proportional. So those are the reasons that you can describe to make sure that you know it's proportional. And again, sometimes this k is just saying it varies directly. It's going to be shown like this as well. When you see one that has a y equals mx plus b, this tells you it does not start at the origin. So that one's going to be non-proportional. Okay, so now give it a try. And these are just like from your quiz. Notice the question says, is this relationship proportional or non-proportional? You should not be writing yes or no. The question is not a yes or no question. It is saying, is it proportional or non-proportional? One of those words should be the answer. So to find out, I'm going to see if the ratio simplifies since it's a table. I'm not going to be looking for the rate of change. I'm not going to be doing this, okay? I'm going to be looking at x and y. Generally, the y is the output, the bottom one. And if you're not sure, read it. Is it goals per dollar or dollar per goal? So I know that I'm looking at y over x. 75 over 1 should be equal to 150 over 2 and equal to 225 over 3 equal to 300 over 4 and 375 over 5. That's 75, which is equal to 75, 75, 75, 75, 75. So they are all equal to 75. All the ratios are. So I would write that this is proportional if I'm asked to explain. I would say that the dollars to goals, the relationship between the number of dollars earned is proportional to the number of goals scored. And I would write all YX ratios simplify to 75, or they are all equal. This was another struggle, writing a scenario for this relationship, okay? So, using the units given to you, so knowing we're talking about dollars and we're talking about goals, and this is where you might want to know your rate of change. So I know that I'm going up $75 for every one goal. So a scenario is kind of like you're writing a word problem. In this case, I might say, Jim is playing in a fundraiser soccer match. He is going to donate $75 for every one goal scored. So I am sharing X and Y, donating dollars for every goal scored, X and Y. I'm also giving the rate at which this is happening, 75 for 1. So if there was a y-intercept, you'd want to include that. In this case, there's not. He scores no goals, he'll give no money, but 75 for 1 is my rate, and that should be described. So one more, describing if it's proportional or non-proportional and writing a scenario. First thing I notice is this graph starts up here at 60, so it has an ordered pair of 0, 60. So right away, I know that I'm not going to write the word no. I'm going to write that this is a non-proportional relationship. And my explanation is going to be the graph does not go through the origin. Simple as that. It's obvious to me that it doesn't. I could also write the ratios are not equivalent. A scenario to describe this. Again, I want the scenario to make sense based on the title of the graph, the labels of the graph, and the information given. So I see, before I write the scenario, I want to know my starting point. I know that I'm starting with 60 gallons. I see that this is it's a draining of a tub. And I see that my slope is I'm going down 10, 20, 30 in 1, 2, 3, 4. So it looks like I'm going down 30 gallons in 4 minutes. Okay, you could simplify that or you could write it that way. So something I might say is, for my scenario, is Mary is draining a large tub. Notice I'm describing the situation. The tub has 60 gallons of water in it. Describing my starting point. Need that. That's your y-intercept. She notices the tub drains. Sorry, my handwriting's crazy with the stylist. 30 gallons every 4 minutes. She's wondering how long it will take for the tub to drain. Another thing you could say is that she is, you could simplify it. 30 over 4, you could simplify that. You could, anything to describe that there is a rate of change and that there is a slope. You just have to make sure that you have all of it included. So that's kind of the rundown of the quiz. Hopefully that you made some connections with the misconceptions that you had. Now you should be able to show your notes and get your quiz back and make corrections on a separate sheet of paper before moving on to the next lesson.